Okay, last part. We can, vertex form is helpful. Again, if you watch part 1, you heard me say this. But vertex form is helpful because we can find vertex form from a graph of a parabola. Standard form, we can't, at least not at this point in our math career. We can know that like A is positive because it's concave up, but do I know if it's positive 1 versus positive 2 or positive 2.2? No. So vertex form we can find exactly, and then we can convert that to standard form if it wants us to find standard form. So in order to find vertex form from a graph or from a table or from whatever, we need to have the vertex, which as always is h comma k, and we need to have any other point, which we'll call plain old x comma y, on the graph. And by graph, it does not mean anywhere on the coordinate grid. It means specifically on the graph of the parabola. So I would really say any other point on the parabola. Okay, so once we have an h and a k, and we have an x and a y, we'll have an h and a k, we'll have an x and a y. The only variable left will be a. So once we plug in everything that we know, we'll be able to solve for what we don't know. So that's the only reason that I'm actually plugging in a number for x and for y here, is so that a will be the only thing left. If I didn't plug in for x and y, then I would have 3 variables and I wouldn't be able to solve for any of them. But if I do plug in for x and y, then I'll only have 1 variable left and I will be able to solve for it. So first thing we do, plug in the vertex for h and k, plug in the point for x and y into our formula. Then we can solve or isolate a, and then we can substitute a, and then the vertex, so the h and the k, into vertex form. So we'll have our vertex form. Then if it wants us to, then we'll rewrite it in standard form, again, if necessary. So in practice, let's see. I'm gonna definitely do 4, 5, and 6. I might get to 7 and 8, we'll see. Okay, number 4. Function g has a vertex at 1, 1 and passes through the point 0, 2. Write an equation for g of x in vertex form. Okay, good to know. All right, so I know that my vertex is at 1, 1. Vertex is always h, k. So h, k. Now, we also go through the point 0, 2, and that's just plain old x and y. Okay, so I'm going to write vertex form, which is y equals a times x minus h quantity squared plus k. And I'm going to plug in what I know. So I know that the y value for my point is 2. Equals, I don't know a yet, so I'm leaving that alone, times the quantity x, which was 0, minus h, which was 1, quantity squared, plus k, which was 1. So you can see now that I have every variable plugged in except for a. So now I can solve for a. Once again, using our very best friend, order operations. So this time, if I look inside the parentheses, I do see like terms because 0 and 1 are like terms. So I'm going to highlight each step. I'm only going to change one thing at a time. First thing I'm going to do is 0 minus 1. So I've got 2 equals a times, now this is going to be negative 1, still squared, still plus 1. So parentheses, done. Now exponents. I do see an exponent right here. So I'm going to do this whole thing squared. So 2 is equal to a times negative 1 squared is positive 1. So a times positive 1 plus 1. Okay, and now here I see multiplication and I see addition. Well, what comes first? Multiplication. So a times 1 is just 1a, or really even just a. So I'll say 2 equals a plus 1. And then now to get a by itself, I can subtract 1 from both sides. And we get 1 equals a. Awesome. So since this wanted my equation in vertex form, I'm going to go ahead and plug in that in into vertex form, which is y equals a times x minus h squared plus k. So this time I do not have to plug in any numbers for x and y because I'm not trying to fill in all of my variables this time. I'm going to leave my x and y alone because that's just input output. I am going to plug in the a, the h, and the k. But my x and my y are input and my output. So I have y equals, my a was 1 times x minus my h was 1, quantity squared, plus k was 1. So this is my final answer. And if I'm being nitpicky, technically it told me that it was a function called g, so I could also have written that as g of x equals 1 times x minus 1 squared plus 1. And if you're asking yourself, do I need to put that 1 right there? No, we do not. So it could just be that instead. Okay, let's do that again on number 5. This time, though, it's going to want us to convert to standard form. Okay, so to start out, though, because I can't find a, b, and c from a point in a vertex, I can find vertex form, though. So we have y equals a times x minus h squared plus k. Okay, let's see what it gives us. The function h has a vertex at -2, 8. Okay, so I got my h, I got my k, because it's my vertex. Passes through, the point of -4, 0. So got my x, got my y. Okay, so we're gonna plug in what we know, just like last time. Y is 0. So 0 equals a, which I don't know yet, times x, which is -4, minus my h, which is -2. So I'm about to have minus -2. I can just go ahead and make that a plus 2 squared plus k, which is 8. Okay, so now just like last time, let's go ahead and solve for a. All right, PEMDAS, parentheses, these are like terms this time. So I'm going to have 0 equals a times this combines to make -2, still squared, plus 8. Now, exponents. I'm going to square this. So 0 equals a times -2 squared is positive 4, plus 8. And just like last time, this is being multiplied, so I cannot add the 4 and the 8 because the a and the 4 are being multiplied. So I can say 0 equals 4a plus 8, and now we're solving for a. So minus 8 on both sides. -8 equals 4a, divide by 4, a equals -2. Okay, awesome. Well, I cannot stop there because that's not what it wanted me to find. It wanted me to find standard form. So I'm going to go ahead and shrink this down, pull it over here. Let's put this into vertex form. So y equals a times x minus h squared plus k. So y equals -2, which we just found, times x plus 2. Remember that h, the sign always flips, plus 8. Awesome, and I'm not going to box that either because that's still not standard form. So let's convert that to standard form. Just like in part 2, these right here, I'm going to start by squaring this whole thing. So we have y equals -2 times x plus 2 times itself because I'm squaring it, and then plus 8. So y equals -2 times x squared, plus 2x, plus 2x, plus 4, and then plus 8 on the outside still. Let's combine like terms. So y equals -2 times x squared plus 4x plus 4 plus 8. Now let's multiply. So y equals negative 2x squared minus 8x minus 8 plus 8. And then now, combine like terms. Last step. Y equals negative 2x squared minus 8x, plus 0, which I do not need to write because these just cancel out. So, since it told me my function was called h, I am going to be a good student and write this as h of x equals negative 2x squared minus 8x. Oops. There we go. Awesome. Okay, very last one, number 6. Function m of x is represented on the graph at the right. Write an equation for m of x in vertex form, and then write an equation for m of x in standard form. So the exact same thing that we just did, it's just that instead of it giving us the vertex and the point, like it already gave us the ordered pairs right here and right here, we are gonna have to pick them from the parabola ourselves. So, starting with what is always true, the vertex is always my h and my k. So this vertex, I'm gonna label it over here, the vertex is at 3, negative 3. So that is definitely my h and my k. Now, I need another pretty point for my x and my y. I see a pretty point here, 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 and here. I've got 6 pretty points to choose from. I don't know why, but this one is speaking to me. I like this one, which is at 5, 1. You do you. If you want to pick a different one, go for it. But my point is at 5, 1, which will be my x, y. Okay, so let's solve for a. We got y equals a times x minus h squared plus k. My y value was 1. I don't know my a. My x value was 5. Minus my h value, which was 3, squared plus negative 3. Okay, so I can just say minus 3 instead of saying plus negative 3. All right, let's solve for a. 5 minus 3 is 2. So I got 1 equals a times 2 squared minus 3. Now I'm going to square that. So I have 1 equals a times 4, which is 2 squared minus 3. I'm going to multiply right here. So 1 equals 4a minus 3. And now I'm ready to get a by itself. So plus 3 plus 3. So I get 4 equals 4a. Divide by 4. A equals 1. Nice. Okay, so plugging that all into vertex form. And I always write my formula first. It just helps me avoid mistakes. So y equals a times x minus h squared plus k. I have y equals 1, which I just found from right here, times x minus my h, which was 3, squared, and then plus, again, plus negative 3, which is really just minus 3. Awesome, and that's in vertex form. Now let's simplify that into standard form. So, as usual, these are not like terms. So I can't use parentheses here, but I can square it. So I'm going to have y equals 1 from right here times x minus 3 times itself, and then minus 3. So y equals 1 times x squared minus 3x, positive 9, minus 3. And if you're asking yourself whether you even need the 1 right here, no, you do not. So do you even need the 1 right here? No, you do not. No, you do not. Okay, so y equals, let's combine like terms. We got x squared minus 6x plus 9, and then minus 3. And combine like terms right here. We get y equals x squared minus 6x plus 6. And that would be in standard form. And I can feel super confident about that answer because my C value is positive 6, which means that should be my y-intercept. Let's check the graph. Oh my gosh, is the y-intercept positive 6? Did it match? Yes. So I can feel very confident that I did this question correctly, because if I had made a mistake, there would be a very low probability that I would still get the correct C value. So I can feel very, very good about my answer. All right, this was longer than I thought it would be. Shout out to you if you watched all 3 parts. I will not be offended if you put me on 2 times speed. If any of this does not make sense still, please email me, let me know, and I'm happy to have you in for tutoring, which is on Mondays, Wednesdays, and Fridays, both before and after school. And you can always just email me and I can film a short video just for you and send it back. All right, well, have fun doing your Vertex form activity.